In this diagnostic module, I'll take you through a heated oxygen sensor pump current DTC diagnosis. A P2238 is a pump current control circuit, low voltage DTC. The wideband O2 sensor is a vital part of an engine's management system. Its job is to accurately measure the oxygen concentration in the exhaust gas and supply this information to the engine control module, or ECM. This sensor determines a much wider range of oxygen concentration than a narrowband sensor and knows exactly how rich or how lean the mixture is. This is a typical schematic for a wideband heated oxygen sensor. They can have 5 or 6 wires. The sensor consists of a heater element, a pumping cell and a NERTZ cell. There's a 2-wire heater. The voltage comes from the fuse through to the heater element within the sensor to a pulse width modulated ground. The pump cell has 2 5-volt pull-up circuits and shares a ground with the NERTZ cell. The pumping cell also incorporates a trimming resistor that is used to calibrate the sensor when manufactured. The NERTZ cell contains the ground from the module and goes to a 5-volt pull-up circuit. When dealing with a current or stalled fault, note it down, clear the DTC and carry out the appropriate test to run and set the fault code. This will verify that other fault codes or issues won't cause misleading diagnosis. Always check the manufacturer's specifications for running and setting the DTC. In this case, battery voltage must be between 10 to 18 volts and the engine must be running. If the fault code returns, check the freeze frame data, as this will contain valuable information. Check the battery voltage before carrying out any testing. A faulty battery can cause these type of faults. It's a good idea to set the range of the multimeter to 2 decimal places. This will give you a quicker reading. If you have a scan tool with graphing mode, check the live data. A way to see if the sensor is functioning is to create a vacuum leak whilst watching the data and see if the reading changes. If it doesn't, the fault could be in the sensor, the wiring or the module. To start the diagnosis, disconnect the O2 sensor plug connector. Before you start testing the circuit, check for any pinched, broken, burnt or corroded wires at the sensor and harness. There's no need to check the heater control, as there is no DTC or malfunction with the heater circuit. Check the harness side of the connector with the ignition in the run position. Check the pump circuit for 5 volts at pin 1. This can be done by connecting a voltmeter between pin 1 and battery negative. Always use the correct test connectors when carrying out these checks. If I don't have 5 volts, the fault could be a short to ground or an open circuit between pin 1 of the sensor connector and the ECM. To check for a short to ground, simply move the multimeter probe from the negative terminal of the battery to the positive terminal. A voltage here will indicate a short to ground. If there's no voltage, you need to check for an open circuit. To check for an open circuit, go to the next connector in the harness and check for the 5 volts. The last check will be back probing the ECM connector. If no voltage is found here, it'll be the connector or the ECM. Unplug the ECM connector and check for corrosion and the correct terminal tension. If this checks out, the fault will be in the ECM. Next, check for 5 volts at pin 2. If there is no voltage, the diagnosis is exactly the same test as for pin 1. They are both pull-up circuits. If you have 5 volts at both pins 1 and 2, move on and check the ground at pin 3. To check for a ground, connect one multimeter lead to pin 3 and connect the other lead to the battery positive. If you have battery voltage, then the oxygen sensor will be the fault. There's two options if there is no voltage, depending on the type of circuit. If the ground comes from the chassis, this will be the next point to test. If there is a voltage present, there will be an open circuit in the harness. If not, it will be in the chassis ground itself. If the ground comes from the module, back probe the ECM connector. Again, if there's voltage here, the problem will be in the harness. If there is no voltage, it will be either the ECM connector or the ECM itself. Check the terminal tension and for corrosion on the ECM connector. If the readings all check out, then the fault can only be the ECM. Once the fault is repaired, clear the fault from memory and carry out the correct drive cycle. Follow the procedure and deal with one part of the circuit at a time. Thanks for watching and bye for now.